welcome back to another lesson. Today's learning goal is I can graph quadratic functions on the coordinate plane and identify key features. Last time we talked about key features, a few key features, mainly increasing and decreasing, where is the function increasing and decreasing, and positive or negative, where the function is above the x-axis and where it's below the x-axis. We also talked about the fact that quadratic functions make a parabola, okay, a big curve, okay, or a big curve upwards or downwards. So here, today we're going to talk about a few more, mainly the vertex, which also goes along with if it has a maximum or a minimum, the y-intercept, and zeros, which we've already talked about in previous lessons concerning linear equations, but we're going to talk about that with quadratic functions now. So, graphs of quadratic functions have several key features. Here, we're talking about a vertex. The vertex is the maximum or minimum of a parabola. Okay, so depending on if it's going upwards like this, okay, opening up like this is going to have a minimum right here. Okay, this is also called the minimum is the y value of the vertex. Okay, so down here. Okay, then we have the zeros. The zeros, just like how it is with linear equations, is the x-intercepts, so the points where the parabola crosses the x-axis, also known as the x-intercepts, or the roots, also known as the solutions, and we'll talk a little bit more about that later on. Y-intercept, the coordinate plane where the parabola crosses the y-axis. Okay, so here this is the y-intercept, these are the zeros right here. Okay, so here it says, label the key features of the quadratic function, then answer A through C. So the vertex is this point right here, and so that's going to be 0, 4. And since this is open downwards, like this is going to be a maximum. Maximum, and the maximum is the y value of that point, so that is 4, so maximum 4. The zeros are the x-intercepts, so that is -4, 0, and 4, 0. And then the y-intercept just happens to be the vertex, so that is 0, 4. It is increasing from -infinity to 0, because you can see it goes from here all the way up to here, and then decreasing as it goes from here downwards, from this vertex downwards. It's positive from -4 to 4, from here to here, and negative when it is less than -4 or greater than 4. Describe the points where f of x changes from increasing to decreasing. Well, it changes from increasing to decreasing at the vertex. As we can see, it goes from increasing, gets to the vertex, and then goes to decreasing. Okay, so wherever the vertex is, that's where the point changes over from increasing to decreasing, or decreasing to increasing if it's opened upwards. Here, describe the points where f of x changes from positive to negative. Well, the zeros are the points where the f of x changes from positive to negative, and also vice versa. You should also write that down. And vice versa. Okay, versa. Okay, because the points where it changes from negative to positive are also where the zeros are at. So it goes from negative to positive right here, and then positive to negative at the zeros. Here, we have a vertex that is right at this point right here. So we have a vertex of 3, -4. And since this is open upwards, we have a minimum of -4. That's the y coordinate of our vertex right there. Our zeros are going to be 1, 0, and 5, 0, because those are right here and right here. And then finally, our y-intercept is going to be right here at this point, and that is 0, -5. Go ahead and try number 3 out on your own. What you should have found is that the vertex was 2, 4. We have a maximum at 4, And our zeros, or x-intercepts, are 0, 0, and 4, 0, and our y-intercept is also one of our zeros, which is 0, 0. Go ahead and try this one out on your own. What you should have found was we have a vertex of negative 4, 0, a minimum of 0 right there, a x-intercept also right here, and then our y-intercept right here.